Welcome to Unit 3, Math 9, Polynomials Review. So we have some keywords. First of all, what the heck is a polynomial? Well, it tells us a polynomial is a term or a collection of terms where the variables have whole number exponents. Well, what the heck does that mean? Well, that means I could have something like this. 3x exponent 1. I could have 4 cubed x squared. Okay, because I could solve this part, remember, for powers. So I get 64x squared. So, polynomial, the terms, the variables have whole number exponents. So my variables here, they have whole number exponents. They're not going to be negative numbers. They're going to be 0 or larger. All right. So if they're sitting side by side, they're one term. That means they're attached, they're multiplying. If they are top and bottom, like a fraction, there's still one term. So if I've got 5y over 2, that means that's still one term. Okay, that is one term. So, what we know that we can't have for a polynomial, so what can't be a polynomial, is if I put a variable in the bottom. What if I put a variable in the bottom? Well, it doesn't get the special name polynomial, but we know how to deal with it. We do it in our powers unit. Okay? So that guy wouldn't get the special name. So, terms, when we separate them by adding and subtraction signs, that makes our polynomials bigger. Okay? So it's kind of like a choo-choo train with each of the cars connected by plus or subtract signs. So, here's one of the boxcars, here's the other boxcar. They're combining and they're connecting by a plus sign. So, here we've got one term and a second term. That's called a binomial. Okay? So, we have three specific names for polynomials. Binomial just showed us that it was two terms. And monomials here. What is monomials going to be? One term. Good. So the monomials are one term. And the trinomials. What do you think the trinomials are going to be? Show me your fingers. Yeah, it's going to be three terms. Good. Now remember, terms are separated by positive and negative signs. All right. Then we talk about what the heck a coefficient is. Well, a coefficient is created from, the word itself is created from a prefix, the C and O. Well, co means something in front. So, coefficient means there's something in front of your variable, and it's a digit. So, the digit is considered to be your coefficient. Now, the digit could be a fraction, it could be a decimal, it could be a square root, it could be absolutely anything, okay? Now, variables, as we know, they represent unknown numbers, and we represent them with variables and letters. So the variables we call letters, letters we call variables. So over here we've got the example 7 and n. The n is the variable in that expression. The constant value, I call those ones the constantly lonely. They're lonely because they're not attached to a variable. Okay, they're by themselves, no variable attached. So when I take a look, when we scroll down here, my constant, and it is telling us it's without a variable. Okay, so 2 is the constant in that question there, in that expression. Now the degree. The degree means all the exponents added together for one term, not for every term. Okay, so for one term. So, example, if there's more than one term, the term with the highest degree is used to represent the polynomial. So, if you've got the example here, 3x squared y, there's a given 1 on that y. So I'm going to add the 2 and the 1 for the exponents. I'm going to get a 3. These guys here, that's a 2 and that's a 1. So this guy's a 2 and a 1. So this guy's called a third degree or a degree 3 polynomial because the variables sitting side by side, we added their exponents. And you can only add them if they're sitting side by side to create the degree. Now the rules say in our exponent laws we can't actually add the exponents to get an answer and move further with the simplification of a question. You can't do that. If they're different variables, you can't. If we're finding degree, only degree, you can take different variables and add their exponents if they're attached. Okay? So if I've got another example, if I've got 3w squared y plus 2z to the 4th cubed squared, I'm going to take a look at these two. They're attached. When they're attached, they are sitting side by side. They're actually multiplying when they sit side by side. 4 and 2, that's going to give me a 6. I look at this guy's 2 and the 1. If I add those, I'm going to get a 3. Who's larger? The 6. So that would be a degree 6 polynomial. Okay? Is how we would name that. All right. We're going to move on down to our chart to see if we can identify the items in each of those. So I'm going to give you a minute, build the chart out, push pause now, and play when you're ready. Okay, let's take it up together now. So for terms, we're going to go straight down in our column here. So the number of terms, remember, they're separated by positive and negative signs. So this one here, 1 term. The next one, 1 term. Over here, I've got 1, 2, 3. That's a 3 term. And over here, 2 terms. The next one, the coefficient. Remember, coefficients only apply to the ones that are attached to variables. So this one would have the -8. Don't forget to take the sign in front. You have to. This guy over here has none of them, not applicable. You could put NA or 0. Or you could write the word none. They have none. Over here, I've got a -2 in front of the b squared. And I've got a -1 in front of that b. Don't forget to take those signs. The negative goes with it. Because remember, if it was an algebra tile, that tells us whether or not it's positive or negative. Okay? Next, over here, I've got a hidden 1 in front of that b, so I have a -1. Okay? Those are my coefficients. Always the ones in front of variables. Now I take a look, and I'm going to find the variable. Well, the variable is just the letter they used. Well, they used a y in this one. They used NA. There's nothing. No, not applicable. No variables there. They use the letter b here, so we have a b squared and a b. And over here we have a b as well. Okay, what do they use? Constant. The constant, as we know, is the digit without a variable. Okay, it's constantly lonely. So in this one, doesn't apply. We don't have one. Over here, it is a constant. The 12 is called a constant. That's all it is. And then we take a look at the next one. It'll be a +10. And then on the next one, it's going to be a -4. The -4 is not attached to the b. If it was attached to the b, they would not have that negative sign in between them. Okay, now we're on degree. Degree is always based on variables. So if we take a look at the degrees, take a look at your variables and the exponents on your variables. So the first one, we only have one variable, so it's going to be a degree 1. This guy is a constant. Do you see any variables there? No, this guy's got no variables. So because he's got no variables, he's considered to be a degree 0. 0 for 0 variables. The next one, degree, we look at our exponents, we circle the ones that we have. We've got a 1 and a 2. 2 is larger, so it's degree 2. Over here, 4 is a degree 0. We don't need that because over there we've got a 1 on our variable, so it's degree 1. Okay, check your work. Push pause down, play when you're ready. Now we're talking about algebra tiles. So they're saying in this question, always read the legend, because on one exam or one assessment, it doesn't matter what it is, they could change the color, whether it's positive or negative, for each question. So always read the legend. So in this one it says, shaded is positive. So I count my objects. These guys represent x squareds. And I've got 3 of them. I have 3 big boxes, so I have 3 x squareds. I've got my 3 long skinny sticks. Okay, my long skinny sticks are my variable x. I've got 3 of them. So plus 3x.
It would be minus because they're not shaded.
Well, they are shaded, but they're shaded dark. Or sorry, they're shaded lightly, but they're supposed to be all shaded. I know, the shading needs to come out proper on there. I don't know why. Okay, the last one. If we take a look at these last guys here, those are our individual units. Those are constants. Okay, the baby boxes. So I've got +2 baby boxes. Try the other 2. These ones are where you have to take out your 0 pairs. I'll do one example for you. We take out a positive and a negative because it's going to make a zero pair. Okay, so cross off all the zero pairs, highlight or circle what's left over, and then write the answer of what's left over. Okay, I'll give you a minute to do that. Push pause now, play when you're ready. Okay, let's take a look and see what you got. So we're going to cross off this zero pair, we're going to cross off this zero pair. I've got 1x squared left over. I'm going to cross off 2 of these and 2 of these. I've got 1 long stick left. That's a positive 1x. And then I've got 4 of those, which I can take 4 of those away. And I've got 4 negatives left. So minus 4. Okay, check your work. See how you did. The next one, we're going to do the exact same thing. So cancel your zero pairs. So we have no x squared. Our large boxes all completely disappeared. We got 3 of those shaded ones. So I'm going to take off 2 and 1 to take off those 3 shaded. Each of those have 1, and each of those have 1. I've got 1 long stick left. So I've got a negative 1x. Let's check our baby boxes. Well, those are all cancel out. I've got 4 down here and 4 down there. That will also cancel. So our answer is just negative 1x. Our answer from all of that becomes a monomial. Very good question. This can also be represented as negative x, because remember, those ones can hide. Okay, but the negative signs cannot, but the ones can. Okay, let's move on to the other diagrams. On these diagrams, they're asking us to find the perimeter of each shape. Well, they're only showing us the outsides of part of it. The first thing you should do is always draw in the rest of what's missing. So, just like we did the surface area. That means if there's an x here, there's got to be an x here. These will be identical. These are all 1s, so there's 1s there and there. This guy's an x, this guy's an x, and this guy's an x. Okay, we're going to always have the guys across from them are going to match identically. Okay, that's why we get those answers the way we do. Now, after we've labeled absolutely everything all the way around the edges, all we've got to do is add it up. So you count how many x's you have, and you count how many little baby 1s you have. So when we count our x's, we're going to get 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 x's. And how many little baby 1s? I've got 4 here, 2 here. How many do I get? Positive 6. Okay, I get positive 6. You guys try the next one. Push pause now and play when you're ready. Okay, hopefully you've got everything labeled. Once you have everything labeled, we're just going to add everything up.
Are you missing a 1 here?
I am missing a 1 right there. Thank you very much. So, when we add everything up, okay, sometimes it's easier if you like to color things, use a highlighter. You can highlight which ones are there. So, I just have markers. I'm going to circle them. I've got all kinds of x's, and they're all 2 x's. So I've got 2, 4, 6, 8, 10, 12. So we've got 12 x's. Okay? Then we've got the y's. Let's count our y's. We've got 1, 2, 3, 4. So plus 4y. And now we're going to count all those individual little 1s. So the individual little 1s, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So plus 10. Okay? That should be your final answer. Now when you look at your final polynomial, it's a trinomial, 3 terms. Are you able to add those variables together? Can you add them together and slam them side by side? No, you cannot unless you are multiplying. Okay? All this is creating your final answer as a polynomial. Okay, moving on. So the next section is adding and subtracting polynomials. The best thing about adding and subtracting polynomials is if you can actually put them top to bottom. You can put them top to bottom and line up the ones that match, meaning if it's an x squared box, if it's a long skinny stick, a variable x, exponent 1, or if it's a constant with no variables. So, in the first example, we've done exactly that. We've lined them up with the ones they match, and all you do is you add top to bottom. So this is going to give me a 7x squared. A negative 9 plus a negative 3 is a negative 12x. And we're going to add our negative 4 and negative 5 and get a negative 9. When we subtract, though, it's a little different. So if we take a look, the next two examples have a negative sign sitting out front. When we've got those negative signs sitting out front, we need to do that tic-tac-toe. Or we multiply the negative 1 in, basically is what it means. All that does is it changes this outside negative to a positive, it removes the brackets, and it changes all of the signs on the inside of the bracket. So this 4 is a hidden positive, he's going to become a negative 4x squared. This negative x is going to become a positive 1x, and a negative 12, or positive 12 is going to become a negative 12. This is what you are going to add to this. Okay? So I'm just going to write this other one underneath. So I've got 5x squared he's matching over here, plus a 3x minus 7. Now I can add those together after I've made sure that I've got rid of that negative sign out front of that bracket. Okay, so you deal with the negative sign, multiply it through the brackets, okay? And now we add top to bottom again. That's going to give us a positive 1x squared. That's going to give us a positive 4x. And this is going to give us a negative 19. Okay? Draw the second one yourself. Push pause down, play when you're ready. Okay, we found a typo. This n over here should be a y. Okay, so please change it to a y. Okay, we're going to go through that question right away here. So, changing this to a y, I change that to a plus sign, and I change all the signs on the inside of my bracket. Okay, so now the 2y squared is positive, the 7y is negative, and the 3 on the end is now becoming a positive. Then I go back to the rule. I add top to bottom. Okay, because the outside negative turned to a positive. So I'm adding top to bottom of the things that match. So a negative 5 plus 2y squared is going to give me a negative 3y squared. I have a negative y up here, which means a negative 1y. Adding a negative 7y gives us a negative 8y. And then over here we've got 8. It's going to be a negative 8. And we're adding 3 to give us a negative 5. That would be our final answer. And it's a trinomial. All right, let's move on to the other diagrams. Okay, here's a couple diagrams. We're almost done in Unit 3. Here's a typical diagram you're going to get. They're going to give you the perimeter. And if they give you the perimeter of a rectangle, we already know that two sides are going to be identical. So this one is 2w plus 3. And we also know that these two sides will be identical. Sorry, one tick there, one tick here. So those two sides will be identical. So they gave us the total amount it should all add up to. So now you just start subtracting. So I've got a total of 6 w's that I need, and I've got 2 here and 2 here. That makes 4. So if I take 6, subtract 4, I'm going to get 2 w's that I need left over. But I've got to share them between two sides. So how many w's does each side get? 1. So this guy's going to get a w, and this guy's going to get a w. Perfect. Now they would all add up to 6 w's. Now I've got a positive 14 I have to deal with. If I add my 3 up here and 3 down here, that's going to give me 6. I still have to get to 14. So if I take 14, subtract 6, I get 8 left over. But that's going to be shared between two sides. So you're going to divide it by 2 to give you 4 for each side. So it's going to be w plus 4 and w plus 4. Oops, not w. Not w plus w. W plus 4. So now if we go back and we count around the outside, okay, we're going to go back and count around the outside. So if I count around here, I've got 2, 3, 4, 5, 6 W's. Perfect. 6 W's matched. I've got 3 plus 4 is 7, plus 3 is 10, plus 4 is 14. It all works. You get the exact same answer. That's a good way to check your work. So the unknown side is w plus 4. All right, now we're going to go to multiplying and dividing polynomials. Okay? Now we're going to multiply and divide polynomials. So here's our rules. When we multiply digits normally, so a digit times digits. So when we multiply coefficients, they multiply by themselves. But we add exponents of like bases. Like bases means same variables. Okay? So when we multiply, we're going to multiply into the brackets. That's called distributive property. And when we multiply something into the brackets, we have to multiply it to everything in the bracket. Okay, when we multiply through, don't forget there's a hidden 1 coefficient there. So the 2 is actually multiplying by the 1, and then the x is multiplied together. They each have a hidden 1 exponent. So you've got x1 times by x1. When we multiply same bases, it tells us we're going to add exponents. So the 1 plus the 1 here is going to give me x squared. So this is going to give me 2x squared. And multiply the 2x then by the 3. It's going to give me a positive 6. The x comes for the ride. That's one way to multiply it. You can always use the area box as well. So I'm going to do the next question with the area box. So this one we use distributive property, which we have the rainbows, the arrows going into the brackets. The next one is similar, but we use a box just to make sure that you don't forget something. So this one I need a 1 by 2 window. So on top I'm going to have the binomial, a 2x and a positive 7. Over here I'm going to have a 3x squared. Now we multiply into the brackets. So we're taking this guy, we multiply him by this one. Remember, you add the exponents of like variables. There's a hidden 1 on that x there. So 2 times 3 is 6. I'm going to add my variables, my x's there. I'm going to get x cubed, 3x's there. Okay? Then I multiply my 7 by my 3 to get 21, and the x squared goes for the ride. Now, to write your final answer, you need to take it out of those boxes. This guy is a positive, so in order to connect him to the other guy, you've got to put a plus sign between them. Okay? So our final answer for this one's going to look like 6x cubed plus 21x squared. Okay? All right. Moving on to letter C. Letter C has only monomials in each bracket. So we don't have to worry about doing an area box window, okay, because they're monomials. That means we can just start multiplying digits and adding exponents right off the bat. So let's take a look at that together. Okay. On this one, like I said, they're just monomials. So with monomials, we multiply the coefficients. 2 times negative 4 is going to give us a negative 8. Then I take my like variables. So I have x's, I'm going to take the x's, and I'm going to add the exponents. So we multiply and we add the exponents variables. So x becomes x exponent 7. 2 plus 5 gives us 7. The next one has y's. The y over here is a hidden 1. Don't forget that. Draw your hidden 1s in. These two guys are going to add together. So we're going to get y exponent 4. That will be your very final answer unless they say solve it if x is 2 and y is 3. They'll tell you what the variable is equal to if they want you to solve it further. But that's as far as simplified as you can go for that question. I'm going to leave the next question for you to do by yourself, letter D. We're going to do letter E and F together. Let's move on. Okay, letter E here. We're going to divide. When we divide polynomials, we do the exact opposite of multiplying. So we're going to divide coefficients, but we're going to subtract exponents. Okay, so dividing, we're going to divide the 8 and the 4. 8 divided by 4 is 2. Now we've got an a exponent 1 on the bottom. So when we subtract our a's, we've got a2 subtracting a1, leaves us a exponent 1 left. And the b hangs out by itself, so he has nobody to subtract to, he's just going to cuddle up beside. B cubed. Okay, that will be your final answer. The final answer for letter D, just for your own information, is going to give you 6a cubed plus 8a squared minus 12a. Okay, that's letter D. For you guys to do it later. Letter F. When you've got more than one on the top, more than one term on the top, a good strategy is to write what's being divided under each one. So this guy's going to go with that one. I'm going to write another one over here, 4a squared b squared, so that I can deal with the negative 16. So again, I deal with my coefficients first. 12 divided by 4 evenly 3 times. Then I deal with my a's. I subtract the a's. Well, what do you notice? A2 subtract A2 gives me 0. They disappear. So you're not going to write a exponent 0. We never write that. Because a exponent 0 is equal to 1. And 1 times anything doesn't change your answer. So the a's completely disappear. So you can cross them off. Now you're going to deal with the b's. You want to subtract the b's. B3 subtract B2 is going to give you b exponent 1. So let's begin from the first part. The second part, we're going to divide, again, the coefficients. Negative 16 divided by 4 gives us a negative 4. We deal with our a's again. A3 subtracting our A2 gives us A1 left over. And then we've got our b's as well. We've got 6 of them. We're going to subtract 2 of them. That's going to give us a B4. Okay, that would be our final answer. Who can tell me why I'm not able to add them together now? Why am I not able to add those together? I'm telling you right now you can't. Why? Okay, great answers. So the reason we can't add them together is the first term does not have an A. Okay, we need an A. They have to be identical, ideally, in both ways. Otherwise, you cannot add them together. Okay, let's move on and find area of rectangles. Okay, finding the area. Find area. Area is always length times width of any rectangle. Well, there's our length. There's our width. So I'm going to take area equals. Always put your monomial, the one term, on the outside of the bracket first. So that means the 3a is going to go first. Then I open a bracket and I put my 4a, subtract 9 inside it. Okay? Now we multiply that 3a into the brackets. So I need to write my hidden ones on my variables. So this is that situation again where coefficients multiply and variables will add exponents. So you're going to get 12a squared. Then the 3a must also multiply to the negative 9. A negative times a positive will give you a negative answer. 9 times the 3 is going to give us 27. But this guy's got the a, so the a has to come sliding over with him. He goes for the ride. Okay? That will be your final area. Okay, that is your final answer for area. Okay? The next question gives us the area and one of the sides. So in this case, I've got this. I've got area equals width times length, and I know this number, and I know this number. So how am I going to find that number? We have to divide out the L, the length. So we're going to take width is equal to area divided by length. Okay? Now why are we dividing? Because we already have the answer of the area. We're working backwards. We have to find out what did we start with in the brackets to multiply. All we know right now is the one out front. So on this one, I'm going to take 18a cubed, subtract 9a squared, divide it all by 9a squared. So when I do that, I'm going to divide my 18 divided by 9 is a 2. I'm going to subtract my exponents because the a's are identical, and I'm going to have a1. Now I've got a negative dividing by a positive. It's going to give me a negative 1. And what do you notice? Your a's will cancel. You have no a's left. So your final answer will be this. So now I've found my length is 2a subtract 1. So now that I know my length, a beautiful question would be, find the perimeter. So if you had to find the perimeter of this question, you would now label all the sides and add everything up that's identical, okay? Add your like terms. When I'm talking about identical, I'm talking about like terms. Now we're dealing with algebra tiles. So again, they've changed our legend for us. This time, our dark tiles are going to be negative. In the questions before, they were positive. So you always have to read the legend. So this one says, draw the algebra tiles in the following expression. Now, sometimes you're going to see it upside down like this. We have often done it this way and not had the line on the bottom, but it's identical. So if you see one like this, it kind of looks like an L, and you want to do it the way we've done it always, you're more than welcome to do this and do it the way we've done it, okay? They mean the identical same thing. So what you're going to do is you're going to take one of the terms, the guy on the outside of brackets. Now he can either go along the left side or he can go along the top, whichever you prefer. I usually put them on the left. So 2a's. Now remember, that's a stick, okay? That's a variable. So it's a variable exponent 1, so it's going to get a stick. So there's one stick, and I've got 2 of them. So there's 2 sticks, okay? I'm just going to erase some of my scribbles I got on there. Let's draw that a little neater for you. So 1 stick, 2 sticks. Okay. Here it says I've got 4 A's, so I'm going to have 4 of those sticks, and then a negative 3. So I'm going to have 1, so 1 stick, 2 sticks, 3 sticks, so I'm going over here, 4 sticks, and we're going to have 3 little ones. 1, 2, 3. I draw very big. I know. I draw it very big. So I'm going to erase it and try and draw smaller for you. I do think you understand what I'm doing, though, the process. So let's draw it a little bit smaller. So 1A, 1A, now I need 4 of them. 1, 2, 3, 4, and then negative 3. 1, 2, 3. It says that the negatives are shaded, so we're going to shade those 3 because they're negative. Now what we do is we find out where the divisions are. By the divisions, I mean where are the lines where the other objects meet. Well, here's a line where those 2 A's meet. We're going to take that line and we're going to draw it straight across. And the bottom line, we're going to draw it straight across. Then we're going to take the top ones where they divide in between each other and draw them straight down. Okay? We're going to draw them straight down. Now we have to see which part is going to be shaded as a negative. So we've got a positive times a positive. There's an x squared, another x squared. We have 4 big boxes of x squared because we have positives timesing by positives. But next, we've got a negative up here timesing by the positives over here. Well, negative times positives will always give us negative. So these three here, and these 3 here, they should be looking like sticks, those are going to be negative, okay? So you're going to write your final answer now. So your final answer is going to be 1, 2, 3, 4, 5, 6, 7, 8, 8 large x squareds, and you've got your long, skinny negative sticks. You have 6 of them. So it's negative 6 x's. Now you can use any variable you want. Before here they used a, so you would say your answer would be 8a squared minus 6a. Okay, you can change back your variables. On the next one, the answer's given to us on the inside. We just have to draw what happened on the outside. So we're going to find where the division lines are and draw them straight down, because this one's reversed for us, and straight across. And then we draw our other line, find out what they would be. So now I've got this, and I've got that. So these, I'm missing one line, one more coming down on the end. So these guys here, we've got a positive timesing my positives. So those are going to be my positive x squareds. Here's my x. Positive x, positive x, positive x. But let's take a look at what happened over here on the next one. We've got a positive x here, and we're getting an answer that's negative. So what do you think I have to have over here? A negative, because a negative times this positive will give you the negative shaded ones here. Okay? So that means these 3 here have to be shaded. They're going to be negatives. So now they're going to say, okay, well, what was your length and width? If this is an area diagram, what was your length and width? Well, the length and width are just the ones that we've created on the sides here. That's those guys. Now we're just going to write them side by side in brackets. So the first one, I've got 2 long skinny sticks, so that's 2x. And it's going to multiply by what I got on the bottom. I've got 1 long skinny stick, and then I got 3 negative units. Okay, so those are little baby squares. So that would be my length times my width, and you always have to put, if it's area, length times width equals the answer. You must put the answer with it. So what do we get for an answer? We have 2x squared boxes, and we have 6 negative x sticks. Okay, they're shaded, so they're negative. So that would be our answer of the area. Okay, the length times the width, and there's our answer of area. Okay, I'll let you finish drawing that in, and we'll move on. The next question wants us to find the perimeter, and then it wants us to find area. Well, perimeter, I do what I did with my last diagram. I find the ones that are the same, so this guy plus this guy are going to be the same length as that big long one. So I'm going to take that top d plus 3, and I'm going to add it to that 4. Okay? Those are all added together for that bottom line.
So then it would just be d plus 7.
Yeah, so now I'm going to add those together, and I'm going to get a d plus 7. Okay. Now I need to find the other missing line. I don't know how big this one is, and I need to find out how big that is. Well, that side and this d are going to be the same length as this 6. So how can I find that piece? How can I find that? Because this plus this equals 6. So let's say I just call that x. We don't know it. So I've got x plus d is equal to 6. How do I find out what x would be? How do I get rid of d? What would I do to d? We subtract it. So I'm going to subtract it over, subtract it over. So this little baby side here is going to be 6 subtract the d. Okay? So that guy is 6 subtract d. Okay, now we've got all our measurements. Okay, I'm going to relabel. I'm going to erase those lines and relabel with the correct measurements. Okay? So this one is going to be 6 minus d, and this guy is d plus 7. So, when I want to find the perimeter, I add up all the variables. My variables, in this case, are letter d's. So I'm going to add my variables. I've got positive 1d, subtract 1d. So what do you know about those two d's? They cancel out, right? They're a 0 pair, plus 1, minus 1. So those two are gone. Okay? I've got 1d here and one more d here. So how many d's do I have altogether? 2. So my perimeter is going to be 2 d's. Now I've got to add my digits. Okay, I need to add the digits. So my digits I've got a 3 plus 6 plus 7 plus 4. And that's going to give me 20. So I'm going to have perimeter equals 2d plus 20.
I forgot the 6
No, I didn't.
on the one side.
Nope.
The 6 minus the d.
Oh, I did so. Thank you very much for noticing that. So we're going to add another 6 there. It's going to be a 26. So my perimeter is going to be 2d's plus 26. Good catch. We did miss a number there. So it's a good idea, just like I did there, circle all of them or highlight them, and you might still forget something. I just did. So make sure you check your work, okay? All right. That's my perimeter. If I want to find area, that object is made up of 2 rectangles. I need to chop that guy in half somewhere so that I can find the area of those 2 rectangles. So, there's 2 possibilities for area. I could chop it this way right here, because I could multiply these 2 and then these 2. Or I could chop it this way and then make object 1 and object 2. Okay? The one that's easiest is to go vertically straight down right where I have it. So for area, I'm just going to erase what we have, and we'll get started with the area question. Okay, so we know area is equal to length times width for any rectangle. We've cut it down this way. So my length is 4 and my width is d. So the area of rectangle 1 is going to be 4 as my length times d. So it's going to be 4d. Okay, that's the area of object 1. Here's rectangle 2. The area of rectangle 2 is going to be length times width. So I'm going to have a 6 times my d plus 3. And then I'm going to multiply my 6 into the brackets, get rid of brackets. So the area of my second rectangle is going to be 6d's plus 3. Now, to get the total, or sorry, plus 18. My goodness, I almost forgot to multiply that guy in.
Yeah, it's just...
Yeah, I caught myself, thank goodness. Okay, last step. Always add both areas together. You need the area of both objects. So the total area is going to be area of 1 plus area of rectangle 2. So area of rectangle 1 is 4d. Okay? Plus rectangle 2, which is 6d plus 18. Now you add like terms. You can add the d's together. You've got 4 and 6, so how many d's altogether? How many d's altogether? 10. 6 and 4 is 10. So you have 10 d's plus 18. Okay, check your work. This concludes the tutorial for Unit 3 Polynomials.